Hello and good morning. Happy Monday, everybody. It's Mr. Taco. My hair is up today because it's real hot in this classroom. And yeah, having long hair on a really hot day can be challenging. Welcome today. Teaching point, adding fractions with unlike denominators. You might be thinking to yourself, wait, we did this on Thursday. Yes, we did. This is day 2 because it is a bit complicated, and we're going to talk about how to keep organized and how to keep all of the different parts that go with adding fractions with unlike denominators, how to keep them all together so we don't get confused and we always understand what we're doing. Okay? That's what you'll need today. Math notebook, pencil or whiteboard marker if you're using a whiteboard, and then your multiplication table if you have one, or if you're using the online one, use the online one, okay? And then down here, here's our teaching points. I can create equivalent fractions, and I can add fractions with unlike denominators. One thing that I was hearing from students was this idea that yes, there are a lot of steps to adding fractions with unlike denominators. If we take this problem, for instance, 3/8 plus 1/3, we're going to have to do about 3 different things in order to figure out our sum, okay? And in order to do that, what we want to do, hold on, the fans are making this multiplication table fly around. There we go. In order to make sure that we're keeping ourselves organized and keeping our all of our pieces in the right place so that we don't get confused on what we're doing, we want to set our paper or set our workspace up a little in a particular way and make sure that we're sticking to that. So I put the word rewrite here because I want to remind myself that when we make equivalent fractions with a common denominator, we're not changing the value of either fraction. All we're doing is we're rewriting it with a common denominator so that we can add it up. Okay, so if I look at eighths and thirds, I'm going to look at my eighths row. I'm going to look at my threes row. I want to know what common multiples show up in both rows. Okay, so for our eighths, I like to start with the larger one because there's fewer numbers. They get bigger real fast, right? So for eighths, for instance, we've got 8, 16, 24, 32. Let's see if any of those show up in the threes row. Does 8 show up? No, it would be here. What about 16? Does 16 show? No, it would be there. What about 24? Does 24 show up in the 3? Aha. So there is our least common multiple of 3 and 8. Our answer is going to be in 24ths. All right, so now we need to think about how do we turn eighths into 24ths? How do we turn thirds into 24ths? So 3/8 times what equivalent of 1 is going to get us 24ths? 8 times what is 24? Well, we can look here. 8 times 1, 2, 3 is 24. So that means we need 3/3. Because remember, this 3/3 is an equivalent of 1. So we're not changing the value of our 3/8. We're not, adding more slices of pizza or taking slices of pizza away. All we're doing is we're cutting the slices we have into smaller slices. 3 times 3 is 9. So here's our rewrite. 3/8 equals 9 24ths. We just proved that here. So all I'm doing here is I'm rewriting our original problem, except I'm doing it in 24ths because that's what we're going to need to add together to get our final answer. Now let's do 1/3. 1/3 times some equivalent of 1 is going to get 24ths. 3 times what is 24? Well, we know 8 times 3 is 24. So 3 times 8 must be 24. And we can even look here. 8 times 3. There it is on our multiplication chart. So we're going to use 8/8 as our equivalent of 1 here. 3 times 8 is 24. 1 times 8 is 8. Okay, so now we know 1/3, go straight down, is equivalent to 8/24. And now we can add them up. So our denominator stays the same. Our numerator is 9 plus 8, or if you wanted to, 10 plus 8 minus 1, right? Go one more and then subtract it. 9 plus 8 is 17, which means our final answer, because 17 and 24 do not have a common factor, because 17 is prime, and 17 doesn't go into 24 equally. 17/24 is our final answer. Okay, so essentially what I did here with our rewrite section is I want our equivalent fractions to be right above and below one another, so I don't get confused on what these fractions are. Okay, I know that this problem here is the same equation as this one below it. Okay, all we're doing is changing the denominators, changing the size of our piece so that we can add them accurately. Okay, let's try one more that way. So if I've got my original problem, I'm going to rewrite that original problem below it with my common denominators, and I can use all my other space to make my equivalent fractions. Okay, so let's try 2/7 plus 1/2. 2/7 plus 1/2. Okay, we're going to rewrite directly below. Something plus something equals something. Okay, so now let's find our equivalent fractions, because we can't add 1/2 and 2/7 straight away. Okay, so let's look in our 7s row. And we've got 7, 14, 20. Oh, I'm already remembering, because 1/2, right? If we're multiplying by 2, it's only going to be our even numbers. So all I have to do is look for the smallest or the least even number. 7, that's odd. 14 is even. Okay? And we can confirm that by looking in the 2s row. We don't see a 7. It'd be right here between 6 and 8. We do see a 14. So our answer is going to be in 14ths. Now, we got to get these 7ths and these halves into 14ths. So let's use our workspace down here. 2/7 times something equals some number of 14ths. 7 times what is 14? 7 times 2 is 14. So we're going to use 2 halves as our equivalent of 1. And then multiply the numerators. 2 times 2 is 4. Okay, so for our 2/7, right below it, we're going to put its equivalent, 4/14. Still following? Great. Now let's put our 1/2 into 14ths. 2 times what is 14? Well, if 7 times 2 is 14, flip them. 2 times 7 still equals 14. So we're going to use 7/7 as our equivalent of 1. 1 times 7 is 7, so we have 7/14. 1/2, 7/14. These are equivalent. These are equivalent. And so then these should be equivalent. 4 plus 7, or 3 plus 7 plus 1, 11. And 11/14, I can't reduce that. So our final answer is going to be 11/14. Making a little bit more sense. It does feel kind of like first do this, then do this, then do this, finally do this, and there's your answer. Okay, the reason we didn't start with this was we want an idea, we wanted a conceptual idea of what it means to make equivalent fractions and what it means to add fractions, right? If we did this in fractions bars, for instance, two sevenths plus 1/2, right? We can't add that yet. We've got to make equivalents. So if we're doing by 2/2, we're doing our 7 pieces times 2. We're making each one a group of 2. To have 1, 2, 3, 4, 14ths. This one times 7 sevenths, so we're making a group of 7 with each one. And then we have 1, 2, 3, 4, 5, 6, 7 14ths. Now, our 4 pieces plus our 7 pieces is 11 pieces. And each piece is the size of 1/14. Okay, so that's how we end up with sort of why we started from the conceptual. So then when we get to this, we can trust in our own conceptual understanding and go, okay, I'm going to trust that the algorithm works because I did the work beforehand to figure out why the algorithm works. Let's go to the digital whiteboard for a couple more practice problems here. So let's start with this one, 1/3 plus 5/9. Okay, so remember, we're making our denominators match. So looking at our, and we're going to put our rewrite right down here. Okay, and many of you caught on already, but 3 goes equally into 9. 9 is a multiple of 3, so our answer can be in 9ths. And the nice thing about this one is we don't have to do anything with 5/9 because it's already in 9ths. Half our work is done. All we need to do is figure out how many 9ths 1/3 equals. Give some more space here. There's the next one. 1/3 times which equivalent of 1 is going to get us 9ths? 3 times what equals 9? Yeah, 3 times 3. So we're going to use 3/3 as our equivalent of 1. And 1 times 3 is 3. So then we have 3/9 plus 5/9 equals some kind of 9ths. 3 plus 5, 8. And you are correct that you cannot reduce that. So 8/9 is going to be our final answer. So 1/3 plus 5/9 equals 8/9. Okay, noticing in here, this is why we're staying organized. We're writing right below, writing our equivalent equation right below our original equation. So there's no confusion. And then we're doing all of our other work kind of off to the side over here, so it's not getting confused. All right, let's try one more. 3/7 plus 1/3. What is our common multiple here? While you're thinking about that, I will rewrite. So that'll be our equivalent of 3/7. That'll be our equivalent of 1/3. And then that'll be our answer, our total. Okay, yeah, this one, the lowest common multiple is going to be that 21, or our 7 times 3, okay? Often that will be the case where essentially you're multiplying the denominators by each other. You're doing 7 times 3 and 3 times 7 to get your 21. Okay, so now let's find our equivalents. 3/7 equals how many 21sts? And 1/3 equals how many 21sts? 7 times what is 21? And a 3 times what is 21? And then you're going to use that equivalent of 1 to expand your fraction. I've been really, really pleased and excited that more and more of you are starting to catch on. Fractions is tough. It really is. It's a tough concept, and there's a lot of moving parts to keep track of. Okay, but I've been very encouraged by how more and more of you are starting to pick it up. We're starting to see more correct answers on our exit tickets, which is great. And the other thing to keep in mind, too, is we are kind of making this a little harder than you're going to need in real life. Thinking about the kinds of fractions that you see in real life situations, you're not necessarily going to see 21sts in real life situations. You rarely cut a pizza into 21 pieces, right? You're going to see halves, quarters, thirds, eighths, 16ths or 32nds if you're measuring something or you're using tools that have that kind of measurement. Okay, so 7 times what is 21? Again, that would be 3, so we're going to use 3/3. And then similarly over here, we're going to use 7/7. Okay, so then multiply straight across. 3 times 3 is 9. So our equivalent of 3/7 is 9 21sts. So we're going to put it right below. 1/3 times 7/7 is 7 21sts. 1/3 is equivalent to 7 21sts. So we're going to put it right below. And then we can add to find our answer. 9 plus 7 equals 16 21sts. And it kind of feels like you should be able to reduce that, but believe it or not, you can't. They do not have any common factors. 21, you can only do 1 times 21 or 3 times 7. 16, you can do 2 times 8, 4 times 4, 1 times 16, but they don't match. So 16 21sts is actually going to be our final answer. All right, there are more problems on the exit tickets to practice. Okay, they're going to stay in this range of between 0 and 1. So remember to stay organized. Rewrite your equivalent equation right below your original equation. Ta-da. Those are equivalent fractions. Okay, we're trying to stay as organized as we can. And then turn in the exit ticket. The bonus questions get a little harder. There's some mixed numbers, there's some mixed number review and that kind of a thing. So try those out. If you're feeling up to it, again, no penalty for a wrong answer on the exit ticket. Give it your best shot. All right, there is no secret word today. We did have one question in the chat that says, are we allowed to check our answers by looking them up online like on a fractions calculator? That's completely fine with me. Make sure you do the work first, though. Okay, I highly recommend checking your answers. Okay, and you can check them, you know, if you have a fractions calculator online or you have a calculator online, you can check that. However, do try the work first. It doesn't do you any good to just do it on a calculator, because then you're not practicing that process, okay, and stretching your mathematical brain. You can do it. Okay, somebody says, do we have to rewrite all the time? It's the simplest way. If you're doing it in your head, it opens you up to making errors. And again, as long as you're staying accurate, great. But for the most part, especially in this intro stage, writing everything out is going to be particularly helpful. Okay, once you get really, really comfortable writing everything out and want to start doing some steps in your head, then there's that. But don't go straight to working in your head. All right? Thank you, everybody. Math Small Group A is starting in about 8 minutes on Zoom, so I hope to see you in there if you have questions or you want extra problems. Otherwise, fill out that exit ticket. Take some breaks, stay cool. You've got PE at 12:30, and then you will be back here on YouTube for science at 1:15. Thanks for tuning in, everybody, and I will see you next time.